All right, welcome to week 13 practice problems. First question says, in the picture, the measure of two angles of triangle ABC are given. Find the measure of arc BC. Okay, so we're looking for the measure of arc BC, and we're given that these two angles are 105 and 45. So we know if we add those together, we get 150. So we've got this triangle inscribed in this circle. So we know the other angle because we know the total of the three angles is 180. We take away the 150 that's already been used up, we get 30 degrees for this angle in here. So I'm going to notate that as 30. So what we can remember is that basically if I can find the central angle, I'll know the measure of the arc. So what happens is when you move this point back to the center, this angle is going to double. So that means that that's a 60-degree central angle, because remember when you pull it back to the circle, it cuts in half. When you move it to the center, it doubles. And that means that my measure of my arc is also 60 degrees. So we're going to say answer choice D is correct, 60 degrees. All right, a circle is inscribed in triangle ABC. Each segment inside the circle is a radius. If the triangle is isosceles and angle B measures 75 degrees, find the measure of angle XYZ. Okay, so it's asking for angle XYZ, which is this angle right here. Okay, so a couple things. Let's use the information they give us. They say it's an isosceles triangle, so these two sides are the same length. And angle B measures 75 degrees. So 75 degrees here. Since it's isosceles, these two angles are going to be the same. Of course, in my triangle, if I know two angles, I can find the third angle. We've got 75 plus 75, that's 150. So we do 180 minus 150 to find this third angle up here, which becomes 30 degrees. Okay, all right, I think that's basically all we know at this point. We do know these are radiuses, so that means that they meet at 90-degree angles with these tangent lines. Since it's inscribed, these are tangent lines. And then basically I'm asked to find angle Y. Well, I can look at this almost like a kite right here, right? This little piece right there. If I focus in on that, I know that this is a 90-degree angle, and this is a 90-degree angle, and this is a 30-degree angle. Well, this is a quadrilateral, and all four of these sides have to add up to 360. So basically, I'm going to take away 90 plus 90 plus 30. I'm going to take that away to find this missing angle here. So that's 210 degrees. So 360 minus 210 is 150, and that's the measure of that angle. Now, alternately, you could cut it down the middle and think of it as a triangle, and you'd say, oh, this is a 90 and 15, this would have to be 75, and this would have to be 75. A couple ways to do it, but either way, you're going to find that the measure of angle XYZ is 150 degrees. All right, two sides of a right triangle are on the edge of a circle. The third side is located in the center of the circle. The radius of the circle is 10 inches. Find the area of the shaded region. Okay. So this kind of looks like we're focusing in on this little corner here, and we really want to just find the shaded region. So first of all, I can find the area of this sector, okay? And I want to take away the area of the triangle to give me this little sliver, okay? So what's the area of the sector? Well, remember, it's a fraction of the total area. So it's the part over 360 times pi r squared. And the radius is 10. So pi times 10 squared is 100. So 100 pi times the part over 360. And what is the part there? This says that two sides of a right triangle. So it tells me it's a right triangle. So we really know that this is 90 degrees. So 90 out of 360, if you use your calculator, that simplifies to be a fourth. So a fourth times 100 pi is going to be 25 pi. So that's the area of the sector here, 25 pi, minus the area of this triangle. Now it says it's a right triangle with the radius of 10. So we can use the 1/2 base times height formula, where of course the base is 10 and the perpendicular height there is 10. So really it's 1/2 10 times 10. So a half of 10 times, well, 10 times 10 is 100, and a half of 100 is 50. So that means this is 50. So it's 25 pi We take away the 50. Now, of course, that gives us the answer. It's not like a number like, oh, it's 13.75. It's just an expression, but it represents the amount that we have. So this little sliver here is 25 pi minus 50. And that's the answer we're looking for. So answer choice C is correct. Okay, 25 pi minus 50. All right, in the figure below, angle ABD measures 80 degrees and angle ABC measures 130. Find the measure of arc BC. Okay, so it looks like we've got a tangent line here, right? You can see this line here, it's just touching once and moving on. So if we know that that's a tangent line, we know we've got this angle here that relates to this arc, right? This arc will be double what this angle ABD is. So what do they tell us? They say angle ABC is 130. So ABC, this whole thing is 130. And angle ABD, which is this little piece, measures 80. So what that really means is this is 80 and this has to be 50 because the whole thing is 130, okay? Okay, so we're trying to find arc BC. So BC is the one that comes down here. So we could find this angle here and realize that it doubles that angle to find the arc, because that's an inscribed angle. But I don't think I know that angle D. So instead, I'm going to use some other inscribed angles. So this inscribed angle is 80. That means that this arc measure should be double that, so 160 degrees here. If this measure is 50, that means this arc should be double that. It should be 100. Well, look what's happening here. We've got two arcs that we know, and then this third arc that we don't know. Well, this just has to add up to 360. So we've already used up 160 and 100. Well, that's 260. So how much is left? Well, you take 360 minus 260, you get that there's 100 left, which means that this arc has to measure 100 degrees. So answer choice D is correct. Okay. All right, which of the following could be the equation of the graph? All right, so this is an ellipse for sure, and because one side is longer than the other side. The question is, which one of these equations could be the equation of an ellipse? Well, you see how the x and y's are on different sides? I don't want to deal with that. I want to move everything over. So what I'm going to do is I'm going to add this y squared over, and I'm going to get that 3x squared plus y squared equals 10. Okay, that's A. If I add the y squared over from both sides, I'll get the y squared on the left, the y squared on the right will cancel. And actually, that's the equation of an ellipse. So I think it's this one, actually. We can double check. If I add the y squared over on this one, I get 3x squared plus 3y squared equals 10. And remember, when these coefficients are the same, it's a circle. So that's not it. On this one, if I do 3x squared plus y equals 10, I don't get any kind of square or circle or anything because it's not y squared. So it's not C. On D, if I actually have to subtract the y squared over, and remember that's a hyperbola. And on E, this is 3x squared minus y squared equals 0. I think this one's just a straight line. So anyway, none of these actually pan out except for A. So A is our ellipse because our coefficients are different and we have a plus sign. All right. If the diameter of the circle is 20, what is the length of the figure 8 inscribed in the circle? So we're talking about length here of this figure 8. So basically it's two circles like this, okay? So what do I have to do is find the, basically the circumference of each of these little circles. Okay, so first of all, it says the diameter of the big circle is 20. So this whole thing is 20. That means this little one is 10 and this little one is 10. And remember, the circumference of a circle is given by pi times its diameter. So 10 pi is the circumference of this little circle. And this little circle is also 10 pi. So we just add 10 pi and 10 pi, and we get 20 pi total. What's interesting is that the circumference of the big circle is also 20 pi. So it actually doesn't make a difference if you kind of break it up into the smaller pieces. Still going to be the same. So B, 20 pi. All right, if the diameter of a circle is 20, what is the area of the figure 8, both smaller circles? All right, so we're asking for the area this time. So it's a similar problem. We know this is 20, so the little one is 10 and 10 for the diameter. Now remember, we're talking about area, and the formula we use for area is pi times the radius squared, not the diameter, but the radius. So really what we're going to say is that the radius is 5. It's half as big. So if I do pi times 5 squared, I get 25 pi. Remember, we usually move the number out in front after we actually know the number. So the area of the smaller circle is 25 pi. Well, since there's two of them, I just add 25 pi plus 25 pi, and that gives me 50 pi. So 50 pi is our answer for the area of that circle. All right, two tangent line segments intersect at a 42-degree angle. Find the measure of arc XYZ. All right, so we know that these are congruent because two tangent lines that intersect are congruent. We also know that there's a perpendicular radius here and a perpendicular radius here. So what I can do then is I can find this interior angle, because again, I've got this quadrilateral here with a 42-degree angle, a 90-degree angle, a 90. I can find that interior central angle. I just say that 90 plus 42 adds to be 222. Okay, so if I do 360, which is the total interior angles of that quadrilateral, take away the 222, what do I get? I get 138 degrees. Okay, 138 degrees. Now, that's X, so that's 138. That's this interior angle here. What that means is that this arc right here is 138. Well, XYZ is just the rest. So all I got to do is figure out what 360 minus 138 is. And that should be 222. So the measure of XYZ, the arc, is 222 degrees. Okay. All right, a circle is tangent to the x-axis at 4 and is tangent to the y-axis at 4. What is the equation of the circle? All right, so we're talking about x-y axis. We're talking about 1, 2, 3, 4, and 1, 2, 3, 4. These are these points of tangency. So what happens is it just barely touches here and just barely touches here. That's the picture of what's going on. So remember, there's only two things we need for a circle's equation. We need to know the center, and we need to know the radius. Okay? Well, the center is at 4, 4. And what is the radius? Well, it's the distance from here to here, which the radius is 4. So when we write our equation, it's x minus the x coordinate squared plus y minus the y coordinate squared equals the radius squared. So of course that's going to equal actually 16. We're going to simplify that. Everything else looks good. So we're just looking for the one that matches. And it looks like answer choice A is correct. Okay. Another thing you could do is you could realize that if this point is on the circle, this 4, 0, when I plug it into the equations, it should make sense. So when I plug in x equals 4 and y equals 0, I get 4 minus 4 squared plus 0 minus 4 squared equals 16. 4 minus 4 is 0. 0 squared is 0. 0 minus 4 is negative 4. Negative 4 squared is 16. Does it work? Yes, it does. So it may not work on the other ones, but it definitely works on that one. And it could work on more than one. So you might have to test 2 points. But I think either way is kind of a good way to do that. All right, a circle with radius of x units is drawn below. Two tangent lines of the circle are shown and intersect at point P. Find the distance of the line segment OP. All right, so we're looking for this line segment ultimately, and I know part of it is x plus 18, and I know that the radius is x units, okay? So basically, I need to know what x plus 18 is. That's my ultimate goal. That's my answer. Whatever x is, when I add x plus 18, right, that's the entire length there. That's going to be my answer. So somehow I need to set up an equation that helps me solve for x. Well, what do I know about tangent lines that intersect? They should be congruent. So that means that this 3x plus 8 should equal this 4x minus 2. Any tangent lines that intersect have the same length. So that's my equation that helps me solve for x. So when I go ahead and solve, I subtract 3x from both sides. 3x minus 3x is 0. That leaves me with 8 on the left side. 4x minus 3x is just 1x. X minus 2, if I add 2, I get that x equals 10. So when I go back and plug this in, I know that it's 10 plus 10 plus 18. It's going to be 38 units. So answer choice C is correct. Okay. All right, next question says, if a circle has radius of 10, what is the length of an arc whose central angle is 80 degrees? Great time for a picture here. Circle has radius 10, and we're talking about an arc length whose central angle is 80. So here's this central angle of 80. The question is, what is the arc measure here? Well, it's just 80. Central angles are equal to arc measures. So that's the measure of that arc length, right? Now it does say what is the length of an arc. So that means we're really doing arc length, which is basically the central angle over 360. It's the part of the circle times the circumference formula, which is 2 pi r. So we know that the part that we're talking about is 80 degrees. So 80 out of 360, that's our fraction of the circle, times 2 pi 10. So radius is 10. So 10 times 2 is 20, so we get 20 pi times 80 divided by 360. Now real quick, do I need to actually calculate a decimal, or do I leave this in terms of pi? All I do is look at my answers, right? All my answers have a pi in them somehow. So I don't really care about the pi. The pi will just come along for the ride. I need to know what 80 divided by 360 times 20 is. So 80 divided by 360 times 20. That gives me 4.44444444. Now, if I want to make that into a fraction, I just say math fraction. So enter, enter. 40/9 is the fraction that I get there, okay? So I get 40/9 times pi. Now remember, pi is just a fraction like pi over 1 is, right? Pi over 1 is the same thing as pi. So when I multiply the tops and the bottoms here, I get 40 pi over 9. But just realize that 40 pi over 9 is the same thing as 40/9 pi. You can either write the pi off to the side, or you can write it up top. In this case, we see that it's 40/9 pi. So answer choice B is going to be our answer. All right, the measure of angle ABD is 10x plus 30, and the arc AD measures 8x plus 90. Find the measure of angle ACD. All right, so we've got the measure of angle ABD is 10x plus 30. So where's ABD? That's ABD. So this right here is, I'm going to put a little arrow there, 10x plus 30. And the arc AD, which is this arc here, measures 8x plus 90. Find the measure of angle ACD. So we're looking for ACD. This is ultimately what we're trying to find. So we've got this inscribed angle, right? This inscribed angle. And then we've got this arc measure. Well, what's the relationship? We know that inscribed angles are half as big as arc measures. So I'm going to write that. The inscribed angle is half of the arc measure. Okay, I kind of wrote that out in words. Well, let's put the actual expressions in there. So the inscribed angle, that's 10x plus 30, is equal to half of, so of means times, the arc measure. This is going to help me solve for x, okay? So I have 10x plus 30. Remember, I have to distribute this 1/2, so half of 8x is 4x. Half of 90 is 45. Now I just solve for x. So I subtract 4x from both sides. That gives me 6x plus 30 on the left side. On the right side, I just get 45 because those 4x's cancel. Okay, I'm going to take away 30 from both sides, and I'm going to get that 6x equals 15. And I divide by 6, I get that x is 2.5, so 2.5. Now, what am I actually trying to do? I'm trying to find ACD, this measure right here. But I don't have an expression for that. But remember, these are shared endpoints here. These two endpoints are the same in both of these inscribed angles, which means those inscribed angles are equal. So I know that this one is 10 times x plus 30, so I could figure out what that is. I could say 10 times x, which we found out was 2.5, plus 30. That's 25 plus 30, that's 55 degrees. Well, that's the same as this one, because they have shared endpoints. If I drew one here, that would be 55. If I drew one here, anything with those two endpoints is going to be 55, unless I go to the other side of this dotted line. Then it's going to be supplementary. But anything to the right of these two lines is going to be 55. So answer choice D, 55 is the correct answer. All right, a triangle is inscribed in a circle such that its longest side is the diameter of the circle. What is the measure of the smallest angle in the triangle? One angle is given. All right, so if this is our diameter, we know that the arc measure is 180 degrees because it's half the circle. We also know that this is a straight angle, so it's also 180 degrees. So that when I pull this back to here, it forms a 90-degree angle. Okay, so basically we have a right triangle here. 90-degree angle, this one they say is 49. Well, we can find this one then. We know that 90 plus 49 plus our unknown angle should equal 180. Right? The sum of those three angles of any triangle should add to 180. Well, I get 139 plus our angle equals 180. I take away 139 from both sides, I get 41 degrees for our angle x. So that's it. The small angle is 41 degrees. Okay? Now I know it's the smallest because we've got a 90 and a 49 and a 41, so I just picked the smallest one, which is 41. All right, what is the equation of the circle that is centered at 1, -1, and passes through 4, 5? All right, so the equation of the circle centered at 1, -1 that passes through 4, 5. Well, remember our formula x minus x1, or I guess we could say x minus h squared plus x minus k squared equals the radius squared. We just plug in what we know. We know that h is 1, so we plug in x minus 1 squared plus x minus a -1, right? That flips the sign to positive, equals the radius squared. Now, we don't know the radius here, but we know something important. We know the center is at 1, -1, and we know that it passes through the coordinate 4, 5. So couldn't I just use the distance formula here to find that actual coordinate, or the distance there? I use the distance formula. So remember, the distance formula is the square root of the difference in the x's squared plus the difference in the y's squared. So the difference in the x's, well, we have 4 minus 1, right? So the difference is 3. And then we're going to square that. And the difference in the y's, well, we have 5 minus -1. The difference there is 6. Now you could draw a picture and just count to find the 3 and the 6, but either way, 9 plus 36, that's 45. So the distance between those points is square root of 45. So that's basically our radius. The radius is the square root of 45. So when I plug in the radius here and I square that, okay, the square root of 45 squared, the root and the square cancel and leave me with 45. So my formula is x minus 1 squared. Sorry, this should be a y. I made that mistake a while back. Y plus 1 squared equals 45. That is my formula, which goes through the center of 1, -1 and through the point 4, 5. So which one looks like that? Looks like it is answer choice D. Okay. Alternately, you could just guess and check here. You could plug in numbers, right? 4, 5 should make the equation true because it's a solution. It's on the circle. So you could take, answer choice B, which says x plus 1 squared plus y minus 1 squared equals square root of 45. And you plug in x equals 4 and y equals 5. You'd get 4 plus 1 squared plus 5 minus 1 squared equals square root of 45. When you do that, you get 5 squared plus 4 squared. That's 25 plus 16. That is 41. Does 41 equal the square root of 45? No, they're not even close to each other. So you know, okay, it's not A. You can move on. You can test points with circles. I think it's just much better to know how to do this one kind of the traditional way. All right, a circle is centered at point O. If triangle AOB is equilateral, what is the measure of angle ACB? Okay. So it says that this triangle is equilateral, so I would make sure I notate that. And then I would realize that these are all 60-degree angles because equilateral triangles get shared, that 180 gets shared evenly between all three. So I've got this central angle of 60, it looks like, okay? What's the measure of angle ACB? So the measure of this angle should be half of that, which is 30 degrees. So kind of a straightforward problem if you just realize that, oh, being 60 means that I cut it in half when I go back to the inscribed angle. All right, in the line segment below, the ratio of AB to BC is 1:3. D bisects CE, and the length of BD is 22. If the length of AE is 36, find the measure of BC. Okay, so there's a lot going on here. I'm going to start marking this thing up. First off, it says the ratio of AB to BC is 1:3. So remember, when ratios are 1:3, it could mean that this length is 1 and this length is 3, or this length is 2 and this length is 6, or this length is 3 and this length is 9, or this length is 1/2 and this length is 3/2. All it means is it's 3 times as big. So in this case, we want to definitely use a variable for x and 3x. Whatever this is, x, this is 3 times that, 3x, okay? Then it says that D bisects CE. So D is in the middle of CD and DE, so that those are congruent, so we want to mark that. Then it says the length of BD is 22. So B to D is 22. All right, it also says the entire length is 36, AE is 36. So going back to the CD and DE are the same. I wish I could kind of write CD in terms of X because I like having one variable, but I don't see any way to make a connection there. So I think I'm actually just going to call this Y and Y. Okay? All right, so let's make some sense of this here. If BD is 22, right? If BD is 22, that means that 3x plus y is 22, okay? And then it says that AE is 36, so the whole thing is 36. What that tells me is that x plus 3x plus y is 36. Now that simplifies when we combine our like terms to just be 4x plus 2y equals 36. So that's really a better way of saying that. So what we have is a system of equations here. We've got 2 variables and 2 equations. So we can do this. I need to make one of the variables go away. And what I'm going to do is I'm going to subtract 3x from both sides. I'm going to solve for y in this equation. So I'm going to write that y is equal to 22 minus 3x. Okay, once I've got y solved for, I'm going to substitute it in for y in the other equation. So I'm going to say that 4x plus 2 times y equals 36. But instead of y, when I said 2 times y, I'm going to put what y is equal to. Well, y is equal to 22 minus 3x. So I can put that in there instead of putting in y. Now, of course, I got to distribute here, but that's okay. 4x plus 44 minus 6x equals 36. Combine my like terms. That's 4x minus 6x is negative 2x plus 44 equals 36. Then I go ahead and subtract my 44 from both sides. I get negative 2x on the left, and on the right side I get negative 8. I divide out the negative 2, I'm going to get that x is equal to 4. Okay, now I could find the y value. I could go back and plug it in, right? I could plug in x equals 3, or excuse me, x equals 4 into this equation and solve for y. But actually, I don't even care about y. If you think about it, I'm finding BC. So that means I need 3x, okay? So that means I just want to find x. So I'm good at where I'm at. So 3 times x, right, is the length of BC. BC is 3x, and x is 4. So really that means that BC is 12. So there's my answer choice 12. So answer C is correct. Now this is actually a really good problem for guess and check. Once you set up this part here where you say, okay, this is X and 3X and Y and all that, you can actually use guess and check pretty well here. And this is a perfect problem also to use that testing strategy of pick B first and then pick D next. Because you can actually tell when you choose a number, you can tell if it's too big or too small. So basically, right here, I could guess B. Remember, you always want to guess B first. So if X was 8.5, we would have AB is 8.5. And then 3 times that would be 25.5. And then Y and Y would have to be the rest to make up the 36, right? Because we know the whole thing is 36. And that leaves us just with this 2Y left over. So we've already said 36 minus 25.5. That is 10.5. D would have to be 5.75 to make that work. But if D was 5.7, or if Y was 5.75, you would see pretty quickly that this wouldn't add up to 22, right? Because 3 times X is 25.5. And if you add that to the Y, which we calculated as 5.75, it's not going to work. So that X was too small. Then you would test D, and you would realize that D is too big. And since D is too big, then it must be the other answer, 12. So there's ways to kind of work your way through this with that guess and check strategy as well. Okay. All right. In the circle, a chord is bisected by AO. If the chord length is 6 inches, find the radius. All right. So in this one, it says it's bisected. So we know that these two side lengths here are equal. And since this chord is 6 inches, that means that this is 3 inches and this is 3 inches. Okay. So it says to find the radius here. So that's actually what we're trying to find, is the radius. So basically, I'm looking at this triangle that I have, and I know that this is 3 because it says it in the picture. This is 3. The question is, what's the radius? Well, do I know that this is a right triangle? I do, because we know that when a chord is bisected by a radius, that it makes a perpendicular line. So, or a perpendicular intersection there. So we do know Pythagorean theorem here. This is a right triangle. So I could use 3 squared plus 3 squared equals the radius squared. And I get that this is 9 plus 9 equals the radius squared. That's 18. And then I square root both sides. I get square root of 18 as my answer. Of course, none of those say square root of 18, so I have to break it down into 9 times 2. And this is 3 times 3. And this is 3 times 3 times 2. So really, it's root 3 times root 3 times root 2. These two come together to make a whole number and leave you with root 2 behind. Of course, if you remember, if these are the same, then it's an isosceles triangle. So we just know that it's a 45, 45, 90, which means it's 3 root 2. Whatever this is, it's that times root 2. So that shortcut is really helpful. But either way, you get the answer of A, 3 root 2. All right, in the following line, the length of AD is 24. The ratio of BC to CD is 2 to 3. If the lengths of each line segment is an integer, which of the following could not be a possible length of AB? Okay, so we know the following line has a total length of 24. Okay, it's 24 units long. The ratio of BC to CD is 2 to 3. So we're going to say 2x to 3x, the ratio of 2 to 3. So remember, that could be that this is 2 and this is 3, or this is 4 and this is 6, or this is 6 and this is 9, or this is 8 and this is 12. This could be 10. This would be 15. Now remember, it can't be that, oh, it's it's a half and 3 halves. That can't exist here. We can't have fractions because it says each line segment is an integer length. Okay, so we really are narrowing down to just these integer lengths. So which of the following could not be the length of AB? Okay, so think about it. If the whole thing is 24, let's say this is 2 and 3. Those are possible lengths because the ratio of 2 to 3. If this is 2 and this is 3, that's 5 total. What does the other side have to be to make 24 in total length, right? Well, this would have to be 19. because 19 plus 5 is 24. And we know the total length of this line segment is 24. Well, what about this one? 4 and 6 make 10. This would have to be 14 because 14 plus 10 makes 24. What about 6 and 9? That's 15. 15 plus 9 is 24. This is 20. 20 plus 4 is 24. And this one can't even happen because it's 25, and we know the total length is 24, so it can't be possible. These are the possible lengths of this side AB, this length AB. So we said which one is not. So that one is, that one is, that one is, and that one is. The only one that's not possible is 16. So answer choice D is correct, 16. All right, what is the center and radius of the circle x minus 10 squared plus y squared equals 36? All right, so remember it's x minus h, and that's a 10, so the x coordinate is a 10, plus y minus k squared. Now remember, there's technically a number right here, it's a 0. Y minus 0 squared is the same thing as y squared, it simplifies down. So you have to recognize when you don't have a number in there that it's going to be a 0 as your coordinate for your center. So that narrows it down to really just A or C. The difference is the radius is 36 or the radius is 6. Well, remember this number here is actually the radius squared. So you have to square root both sides to actually calculate the radius. So answer choice C is correct because the actual radius is 6, because we see a 36 in the formula. All right, if a circle has a radius of 2, what is the area of a sector whose central angle is 30? All right, so what we have is we have a circle with a 30-degree angle in the center. We're asked to find the area of the sector. So remember, the area of a sector is just what fraction of the circle we're talking about. So it's 30 out of the 360 total interior degrees, times the area formula, which is pi r squared. Now it says the radius is 2, so we're going to say 2 squared, that's 4. So really 30 out of 360 times 4 pi. All right, now look at all our answers. They're in terms of pi, so I actually want to just leave the pi where it is. So I kind of just ignore it and bring it down. And then this is what I'm actually calculating. 30 divided by 360 times 4. So 30 divided by 360 is that fraction times 4. Gives me that. That's a third. If you forgot that, you do math, fraction, enter, and you get 1/3. Okay, so 1/3 pi, and remember when we write that off like that to the side, it usually pops up on top. So we're going to say pi over 3, which is answer choice B. All right, that's all we got. Appreciate you guys being here. See you next week.